Next, let us invite Mr. Samson Hu, co-CEO of ASUS. He will talk about AI data center layout and development. Welcome, Mr. Hu.
Ladies and gentlemen, a round of applause for Mr. Hu. Distinguished guests, friends from the media, good afternoon. It is my honor to come here today. As we are seeing ubiquitous AI applications, I think we should also focus on the deployment and development of AI data center. To start with, AI data centers have two important driving forces. I think that we all can agree that AI and LLM have seen explosive growths over the past 2 years, especially after the advent of Transformer in 2018. The numbers of parameters are growing by 256 folds within 2 years, every 2 years. So this is the explosive growth that we are seeing. And it is also a challenge that we are facing. Also, as we're seeing more development of AI technologies, AI applications are also evolving as well. From the early days, we have the perception AI, and now we are seeing AI that help us create text, code, and images. And in recent years, we are seeing AI with the capacity of reasoning and planning. So that's the agentic AI. So I believe that you have heard Jensen Huang's speech. So they are now focusing on physical AI. So in the future, we can imagine that AI will be able to gain more awareness. And our holy grail of AI application is the AGI. This will be the development that we will go through in the future, be it the LLMs or the AI technology and applications. All of them represent huge computing, and that means AI server and AI data will be growing at the same time. According to Bloomberg's statistics in April, the growth of AI servers will reach more than 300 billion in 2030. So this is, of course, an exciting number, and I do hope that this will come true, because that's the year in 2032. So if we compare training and inference, the inference will have a growing computing capacity of 44% every year. This also echoes the news media's CSP coverage. For example, Microsoft just started to invest more in their inference computing. So people have been talking about DeepSeek. So it's basically so we often jokingly said that it's AI for the poor. So what we are seeing right now is that DeepSeek will allow more businesses and developers to use AI computing in a more affordable way. And this, of course, will create a positive loop. And it will be used in inference application as well. That is why we are seeing an estimate of 44% of CAGR in inference by Bloomberg. In addition to inference, the training computing power will also grow at a rate, a CAGR of 18% every year, according to Bloomberg. So I think this is something that we can, well, this actually also shows that the AI development will go through all of the stages that we talk about. Our holy grail is, of course, the AGI that we talked about. So we will need a lot of computing power. So when DeepSeek was launched, a lot of people were really concerned, but I don't think that this is something we need to worry about. The development of AI data center started from big five CSPs, for example, Google, Microsoft, or Amazon. They focused on pre-training of the LLMs and inference. Now, as LLMs became smarter and more advanced, we are seeing more and more small language models, and they are more domain specific. So they have also catered to local computing. So on the local end, the data center found by the enterprises are also maturing. The enterprises can also have their data centers. They can use post-trainings. So they can use their specific data sets to fine-tune the models. At the same time, with hybrid structure, they are able to support complicated AI computing that occurs once in a while. So this will allow a more flexible solutions when it comes to cost. So now I'm going to talk about cloud AI data center and local AI data centers. So let's focus on cloud AI center first. According to our years of experiences in building AI data centers, basically, cloud AI data center will have four layers of structure. The first is the hardware-based, the infrastructure. Of course, the source of computing power, that's the GP server. And there's also the parallel storage and high-speed internet. And the second thing is GPU support management software. So it will allow thousands of GPU to be operated. So that's the virtualization technologies and resources deployment. This will allow multiple users to use these GPUs in a more flexible manner. And the third layer is the user portal and AI platforms. So AI will, of course, be a key development priority for all industries. So the user interfaces will be the key here. The fourth layer is deployment and services and operation. AI data center demands a high capacity to integrate, deploy, and operate, as well as performance fine-tuning. With that, the clients are able to have a stable, high computing power at their disposal. And I think that this is familiar to you. There are the bottom layer AI infrastructure. The reason why we're seeing rapid AI development is because of the growing computing capacity. So these hardware equipment can process huge amount of data. Just imagine 3 years ago, in a server with 8 GPUs will have 5,000 watts. And now HGX has a power consumption around 10,000 watts to 12,500 watts. Now, the GB300 cluster will have a power consumption of 135,000 watts. So I think that Mr. Ling is probably the happiest man right now because this entails the opportunities for cooling solutions. In terms of hardware, the AI server, GPU has different brands and different structures. Every year, new technologies emerge. So in the AI data centers, there are four challenges in operations. The first is GPU generation. In the past, every 2 years you would see a new generation, but now we are seeing this occur at once every year. So our clients are concerned whether or not we can have a cluster that can manage different generations of GPU. That's our first challenge. The second challenge is the GPU technology. In addition to NVIDIA, AMD, Intel, or the CSP's TPU have now entered the competition. So how can we manage different sources of technology within one cluster and allow more options? This is our second challenge. The third challenge is the CPU, the computing architecture of CPU. In addition to Intel and AMD, they have their x86 structure. NVIDIA is also promoting their ARM structure. So this is the third challenge. The last one is the service model. AI will have different workloads. For example, virtual machine, bare metal, or container, or other different computing. So of course, we want to cater to different clients to ensure that the GPU can be maximized in terms of their operation. The infrastructure of AI data center, of course, has a key factor here that's network. That there's east-west compute fabric. So you can see this from the description here, and there's also north-south storage fabric that connects server, and there's also in-band and out-of-band management network. So with all of these connected together, the data center can operate smoothly. This is storage. Every day, data centers will handle a huge amount of data according to data types, data scales, and access frequency, as well as their budgets. The clients will continue different types of storage. Moving on to the second and third layers of software, there's GPU resource management. This is the core to the cloud AI data center. So there's the virtual VMware, and there's also GPU. So like I said, GPU will be expensive because GPU supported computing power will have to work on their budget. So this will be based on their back-end management. In the process of establishment of a cloud AI data center, a professional design, establishment, and operation, if you can coordinate all of these things together, you will be able to succeed. So we will have to help the client to ascertain their workload and provide consultation. Now, on day one, day one, the implementation phase, we need to focus on GPU server and testing, and also the GV management software. All of these must be integrated. Last but not least, day two operation. You will need a professional team to handle the daily operation and monitoring of systems so that your system can achieve service level operation. So the infrastructure of data centers include electricity, cooling, and layout. All of these will take into consideration the possibility of expansion of computing power in the future. So we talk about these cooling solutions. Traditional data center relied on air cooling, so you will need AC or maybe the liquid systems. Now, in the new data center, they have equipped liquid to air or liquid to liquid cooling solutions. So it depends on the electricity capabilities. Overall, the performance fine-tuning of infrastructure is also crucial here. So there are three parts. The first is to look at the clusters, and we have Hyper's impact. I think that you all are familiar with this, and there's also the energy saving management standard, BUE, and there's also the software for machine learning and hardware performance. To accelerate the deployment and management of AI data center, we can use management software. At ASUS, we have two solutions. So you will see the AIDC, the ASUS Infrastructure Deployment Center. This helps our client to automate their deployment and lower their TCO. And the other one is on the right, the ACC, ASUS Control Center. This helps our client to monitor and manage remotely. In Taiwan, ASUS has established our own AI center. Starting from 2011, we have been helping governments and enterprises building their data centers in middle scale or large scale. So there's been 8 of them. Last year, we worked with UV Link. So we were working together to construct Taiwan's largest AI data center. So it is actually located in Tuchen. And according to the top 500 ranking, this data center ranked 31st. And the Green 500 list, it came at 44th. Now, in the interest of time, I will have to skip some parts of my slides. And now, moving on to local AI data center. Local AI data center focuses on enterprises, government, or other institutions. The hardware, infrastructure, and software are not that complicated as the ones we talked about. The computing power does not need to reach petaflop. So there's EU, there's 1U, 2U, and 4U. And there's also the workstation or the GP10 announced by NVIDIA. So you simply need the workstation level and it relies on the large language models or small language models. So with fine-tuning model software, it can be used in different application fields. For example, the management of knowledge management of enterprises. Local AI data centers have the capacity of local computing and privacy, security, and domain specific. In recent years, it has become more and more smart. It has become smarter and smarter and more efficient. And there's also the DeepSeek, R1, Meta, Llama 4, Scout, Microsoft, and everything, as you can see on the slide. Local AI data centers have a huge potential according to different surveys and investigation reports. By the year 2033, we will see 33% of CAGR every year. And small language models and market potentials are also huge. You can take a look at the slides here. Local AI data center hardware solutions have been touched upon, and you will see the parameters as shown here. At our local AI data centers, we have fine-tuning language models. It could be used locally. Last but not least, to conclude, starting from 1995, we are seeing the information everywhere. Generative AI will create knowledge everywhere. It's a paradigm shift. So different sizes of language models will enter our daily life. So we are seeing our development in the AI development. So all of these are the experts in AI. Of course, Jensen Huang said that in the future, we will see humans interact with robots. And Meta's AI scientist Yana Liken also said that AI will understand the physical world and have long-lasting memory. And in the future, you will see that AI will continue to advance. Our work and our life will be pushed to new boundaries. So AI data centers will see huge potential and imagination in the future. So that concludes my presentation. Thank you.